Electrical work in schools must adhere to the National Electrical Code, specifically Article 517, which addresses educational occupancies. Depending on the location, a licensed electrical engineer may need to design and oversee the electrical work. Accurate as-built drawings of the existing electrical system are crucial. These drawings should show circuit loads, panel locations, and wiring. If these drawings do not exist or are outdated, they will need to be created or updated. Schools present unique safety challenges due to high foot traffic, potential vandalism, and the presence of children. Most receptacles in schools must have ground fault circuit interrupter, or GFCI, protection to prevent electrical shocks. Circuit breakers must be correctly sized and located to protect against overloads and short circuits. Wiring must be installed in conduit or other approved raceways for safety and durability. Several factors contribute to the higher cost of electrical upgrades in schools compared to residential settings. Firstly, the requirement for a licensed electrical engineer. Secondly, the creation or updating of as-built drawings. Thirdly, additional safety measures and specialized wiring techniques. Fourthly, higher labor costs due to the need for skilled electricians. To approach this project effectively, firstly, consult with a licensed electrical engineer to discuss the specific needs and get a cost estimate. Secondly, check with the local building department for additional requirements or permits. Thirdly, gather any existing as-built drawings and electrical inspection reports that are available. Fourthly, determine if additional circuits are necessary or if the existing circuits can be redistributed. Finally, obtain multiple quotes from licensed electricians before making a decision. It's important to consider the extra safety measures required for electrical upgrades in schools. Working with a qualified electrician is essential to ensuring the project complies with all regulations. Ground fault circuit interrupters, or GFCIs, are crucial in schools to prevent electrical shocks, especially in areas accessible to students. Article 517 of the National Electrical Code, or NEC, provides specific guidelines for healthcare facilities, but its principles regarding safety and reliability are often applied to schools as well. Consider the impact of downtime during electrical work and schedule upgrades during school breaks or off-peak hours. The design should incorporate future needs, allowing for easy expansion or modification as technology evolves or enrollment increases. Ensure that all electrical panels are clearly labeled with circuit directories to facilitate maintenance and troubleshooting. Regular inspections and maintenance are essential for identifying and addressing potential issues before they become major problems. Consider energy-efficient lighting options such as light-emitting diode or LED fixtures to reduce energy consumption and lower operating costs. Evaluate the use of occupancy sensors and daylight harvesting systems to further optimize energy efficiency. Implement surge protection devices to protect sensitive electronic equipment from voltage spikes and power surges. Consider the installation of a backup power system such as a generator or uninterruptible power supply, or UPS, to ensure continuity of operations during power outages. Ensure that the electrical system is properly grounded to minimize the risk of electrical shock and equipment damage. Use appropriately sized conductors for all circuits to prevent overheating and voltage drop. Avoid using aluminum conductors in branch circuits, as they are more prone to corrosion and failure than copper conductors. Use tamper-resistant receptacles in areas accessible to students to prevent them from inserting foreign objects into the outlets. Install signage to warn of electrical hazards and restricted access to electrical equipment. Provide training to staff on basic electrical safety procedures and the proper use of electrical equipment. Keep all electrical equipment and wiring in good repair to prevent accidents and ensure reliable operation. Conduct regular load calculations to ensure that the electrical system is not overloaded. Use appropriately sized and rated electrical components for all applications to ensure safety and reliability. Avoid making unauthorized modifications to the electrical system, as this can create hazardous conditions. Consider the use of arc fault circuit interrupters, or RFCIs, to protect against electrical fires caused by arcing faults. Ensure that all electrical work is performed by qualified and licensed electricians. Maintain accurate records of all electrical work performed, including permits, inspections, and as-built drawings. Communicate clearly with all stakeholders throughout the project to ensure that their needs are met and any concerns are addressed. Conduct a thorough review of the electrical system design before beginning construction to identify and correct any potential problems. Use high-quality materials and equipment to ensure the long-term reliability and durability of the electrical system. Follow all applicable codes and standards to ensure the safety and compliance of the electrical system. Conduct regular safety audits to identify and correct any potential hazards in the electrical system. Provide adequate lighting in all areas of the school to ensure safety and security. Install emergency lighting to provide illumination during power outages. Use non-combustible materials for all electrical installations to minimize the risk of fire. Provide adequate ventilation for electrical equipment to prevent overheating. Protect electrical equipment from moisture and corrosion to prevent premature failure. Use proper grounding techniques to minimize the risk of electrical shock. Avoid running electrical wiring through areas where it could be damaged or exposed to moisture. Use conduit or other protective measures to protect electrical wiring from physical damage. Provide adequate space around electrical equipment for maintenance and repairs. Ensure that all electrical connections are tight and secure to prevent overheating and arcing. Use appropriate tools and equipment for all electrical work to prevent injury and damage. Follow safe work practices to minimize the risk of electrical shock and other hazards. Isolate electrical equipment before working on it to prevent accidental energization. Use lockout/tagout procedures to ensure that electrical equipment remains energized during maintenance and repairs. Test electrical circuits and equipment before energizing them to verify proper operation. Wear appropriate personal protective equipment, or PPE, such as gloves, eye protection, and hearing protection when working on electrical equipment. Use insulated tools and equipment to prevent electrical shock. Avoid working on electrical equipment in wet or damp conditions. Follow all manufacturers' instructions for the installation, operation, and maintenance of electrical equipment. Keep electrical work areas clean and organized to prevent accidents. Dispose of electrical waste properly to protect the environment. Educate students and staff about electrical safety to prevent accidents. Promote a culture of safety in the school to minimize the risk of electrical hazards.